Hello everyone. So now I'll be looking into the molar mass volume, determining the molar mass volume by using acetic acid and sodium carbonate and sodium bicarbonate. We'll be measuring the carbon dioxide gas and the amount of water displaced. So overall experimental design was pretty straightforward. Two flasks with two rubber stops, one with one hole and two with two holes. Uh, the one with one hole will have 3-inch rigid tube, and the other one would have 3-inch and 6-inch. And 6-inch rigid tube has to be submerged in distilled water, which are then connected using the pipe, and those pipe will collect the water into the graduated cylinder. From the safety perspective, since nothing was harmful in this experiment, I wore gloves, glasses, and the apron, the plastic apron. Other than that, I carried out the experiment in ventilated area, and when gases were produced, I made sure that I'm not right on the top of the flask, and I quickly closed the flask with rubber stock. Now, coming on to the results. So these are my results for 4 trials. So the pressure at my area is about 0.97 atmosphere, since my city is located at like 250 meters above the sea level, and at this temperature, this is what the barometer pressure would be. Mass of the chemical was always 1 gram. So I see there is a huge displacement. There's a huge displacement in this and this. Partly the reason why is because the first time when I did the experiment, the rigid tube, the 6-inch rigid tube, was submerged in the water, but was not submerged enough in the water that all the gases would actually cause the water to go. All the gases would actually displace the water. So second time when I did the same experiment, so my order of experiment was like this. First I did this one, 2, 3, and 4. So that was my order of experiment. So for the first time when I did it, the rigid tube was not fully submerged in the water. That is the reason why the displacement was less. I mean, it was submerged in the water, but it was not submerged deep enough. But the second time I pushed it down a bit, and I could see that, and I was quite faster while putting on the flask rubber cork on the flask 1 when the gases were produced. So that time the displacement of the water was quite high. As you see, once I put the submerged the 6-inch rigid tube twice the depth than the previous trial, I got the result which was like almost double of the previous one. Now coming back to the number of moles. So the average moles for sodium carbonate was 12.135, and sodium bicarbonate was 4.66. So this is experimental volume per mole of carbon dioxide. So experiment volume of mole. This is experiment volume of mole for carbon dioxide, and for trial number 4. For trial number 4, I did the experiment. I did the calculations, and the percentage error for trial number 4 turns out to be 13.49%. Probably because it takes some time to put in the rubber cork on flask 1 as soon as the gases are produced. So probably this could be due to the loss in some of the gases. Now, what role did vapor pressure play in this experiment? I used the vapor pressure, that is water vapor pressure, to calculate the amount of carbon dioxide produced for my environment. So that's the role that water vapor played in this experiment. And to sum up the sources of error, the first one would be how deep you put the 6-inch rigid tube in the water. based on that, the amount of water displaced would be accurate. Second would be the human constraint of putting in the cork on the top of the flask one, so some of the gases might escape. So these are the two sources of error in this experiment. Coming back to critical thinking part, what effect does the limiting reactant mass have on the molar gas volume? So the limiting reactant over here is sodium bicarbonate and sodium carbonate, and it has a huge impact because as the amount of sodium bicarbonate and sodium carbonate will determine the amount of CO2 produced, and in return it will determine how much water will be displayed. And since the experiment is carried out at the same conditions, that is, temperature has never changed, and barometer and atmospheric pressure has not changed, so the amount of chemical or limiting reactant that is used in this experiment is highly critical, because it completely determines the amount of carbon dioxide produced, and it will in return displace the water, so that will affect the result of the experiment. Coming up to the self-reflection part, how did this module connect to what you have learned? So this module helped me learn quite a lot about Avogadro number and ideal gas law. So mostly like I've used PV is equal to nRT a lot, but this equation has been used in physics for a long time, since the school time, but I think I gain a different perspective of ideal gas law, and how the ideal gas law is just ideal, and it does not fully apply to the real world. In real world, we have to use the constants, Avogadro constants, A and B. I think I'm just naming it wrong, but I think you know what I mean. It's just like we calculated in the quiz for the real gas of, I think it was lithium chloride. We calculated the pressure using the coefficients A and B, which I took from the chart. So all this, actually, I'm not sure how I could connect it to my personal life yet, because honestly, I've never actually used the gas pressure, the ideal gas law in real life, but to a certain extent of what I could think, that sometimes when you're doing fun experiments like blowing up the balloon, or putting in the water, or some sort of experiments that would help me that would require understanding of this pressure, volume, and temperature. At that point, I could definitely relate it to the ideal gas law and work it out that way. And that's about it. I'll put in the all the calculations that are done into the tabular format during the submission, and that's it. Thank you.